Hello, my name is Marius Solomon. I am the PhD engineering and I want to discuss about my research analysis of three-phase induction motor operation under severe condition. The research contained theoretical approach, of course abstract, analysis of the severe condition, data analysis which I record, and also the conclusion. The objective of this research is to identification of the factors that generate the severe condition and also the analysis of the impact of the several factors on the three-phase asynchronous motor. About the abstract, this paper investigates the operational performance of in three-phase induction motor in real life. The motor is running in the severe condition with VFD, and the research focus on the monitoring and analyzing the behavior pattern of the induction motor operating under a severe dynamic regime in the subterranean environment, providing insight into the factors that lead to the unpredictable performance and reduced service life. When we discuss about the theoretical approach, we have here the equation of the motors, and that means the speed, and we focus on the ABB Baldur motor. The motor has 1000 RPM, and it's important also the torque, because the torque, nominal torque and the nominal speed reach under a curve which is mentioned in the right with the blue color. Also, the theoretical approach, it's mandatory to highlight the harmonics and interharmonics, because the total distortion factor of harmonics should be less than 8%. It's the acceptable limit of the harmonics. I mentioned it's a motor in the real industrial environment, and we have in the right the picture with the motor. It's covered because it's covered, and the motor work like that in a cage because it's covered by the seeds all the time. And when the motor work with a lot of dust, work with poor cooling, because we don't have so much air in the cage, and also we have harmonics because this motor is fed from VFD, and this motor, it's a standard motor, it's not inverter duty. So we have couple things to analyze. First of all, the environment, dust and temperature. Otherwise, another issue, another problem coming from using standard motor instead of inverter duty motor. That means we have problem with electrical insulation, thermal management of cooling, bearing protection, and not in the end we study about the torque capability. Because of the standard motor, we have the nominal torque just one nominal frequency, that means 50 Hertz, and with VFD we provide the variable frequency, that means variable speed and also the torque. I record the data with a special device. That device it's an three-phase electrical network analysis, and it's capable to record the harmonics, the current, and also the voltage. The parameters which I research and looking for, I mention it's also the voltage, and we see in this picture the voltage harmonics. In the left we have the real harmonics, and the level of harmonics we saw it's around 44%, the harmonic number 5, so it's huge. And also we have the big problem with the voltage three phase. It's not with proper phases. It's all the phases it 0 degrees, so we think we have only phases, but it's 3. In the right, I simulate in the virtual environment with the same value the harmonics, and the harmonics looks soft than in reality. So that means the motor it's under big stress of harmonics. Another voltage, another record who show us the entire picture of the harmonics. Also, I study and I looking for the current harmonics, and if you see it's the worse than voltage harmonics, and that means the level it's higher, and also the current it's 180 degrees dephases. So that means it's look like we have just two phases, two current which is consumption. And also in the simulate harmonics we have soft curve comparing with the reality in the left. Another record show us the entire picture. That means the harmonics in the shape of the current. In the end, I want to highlight the effect of the motor. I have two type of problem, like I mentioned in the beginning of the presentation. First of all, I like to discuss about a burned motor because current harmonics and poor cooling give us in the end the burned motor with the coil destroyed, and also the magnetic field effective. And we saw the almost blue color of the magnetic part of the of the picture below. And also to another motor, we saw the bearing destroyed by the current, because we in the standard motor we don't use the isolate bearing. That means the current, the entire loop of the current, destroy the balls of the bearing. In the conclusion, operation with a standard motor from VFD damage the motor until destruction. Step by step, day by day, and in the end, it's a predictive result, the damaged motor. The severe condition, dust and the temperature, generate downtime of the entire installation, and beside downtime, if we discuss about the total cost of ownership, we must take into consideration the cost of the motor and the cost of the manpower to maintenance and to repair, and also to change the motor. And I want to highlight something, the simulation in the virtual environment. That means use let's say specialized software, not give us the entire let's say picture of the reality. It's a gentle picture. That means the record it's worse than the curve generated to the special software. Thank you for listening, and if you have some questions, please feel free to send me. Thank you.